So yeah, to wrap up the webinar, we would like to share with you what we think the future holds for charging technology. We cannot avoid the biggest interest that recent years we've seen on how can we replenish electric freight trucks within a reasonable amount of time. So by law, truck drivers are supposed to have breaks of 45 minutes in between after 4.5 hours of driving. That's mandatory. So it's no, and given the fact that in that range you can approximately drive about 500 kilometers, you should be able to replenish those batteries with a rate that recovers those 500 kilometers for the next part of the shift. That's why the megawatt word has come so largely discussed. So far, we are in the lower range of the megawatt charging capability, so we can find a lot of commercial products that can reach up to 1.2, 1.5 megawatts charging power per charging stop. However, this is just the beginning, and the expectation is that more and more power should be achievable using these chargers. Since we are in the bottom or in the very beginning of that range, the way that these initial solutions were deployed were based on the same power electronic building block for the lower power ratings chargers. So typically you see blocks of 50, 75, or even 125 kilowatts per charging stall. But if we want to really recharge megawatt vehicles beyond what the megawatt charging standard it's predicting to achieve, which is slightly below 4 megawatts, we need to kind of change the mindset and try to use a different granularization. So it's not a surprise that everybody in the business is doing power electronics in a modular way. It's a simple way, it's flexible, we can scale solutions, we can adapt our product to the amount of power being demanded by our customers, but still the granularization or the size of the module is not enough if we're thinking about charging vehicles at 6 or 10 megawatts in the future. And that poses interesting opportunities for power electronics engineers because deploying modular converters in blocks larger than 100 kilowatts, it brings a lot of challenges, not only from the power conversion side, but also in terms of mechanical layout. How do you handle the thermal stress of the different part? How do you place these modules within a frame which will probably have little to reduce ventilation and stuff like that? Also, the magnetic design becomes an issue, and the power ratings also increase the challenges and also opportunities of developing newly and creative power converter structures. On the other hand, the larger power we provide to our loads means that the larger power we're draining from the grid, making to reconsider that, is it still safe, or is it still cost effective to draw 1 megawatt from a 400 volts connection, or 3 megawatts from a 400 volts connection? So deploying alternatives or deploying power structures directly into medium voltage, it's also the next way to go, right? You can simplify protection mechanisms because you can use your grid interface partly as a protection device. You can drain the same power, but with reduced current levels because you're at a higher voltage level. So the electrical connection becomes, it uses less copper and so on. And more importantly, you could invest in some higher sophistication of your power converter, because the larger the load you become to the grid, the more responsibilities you're expected to hold in terms of providing services to the grid in terms of support, as Stefan just explained. So yeah, just to wrap up, we are a bit over the time expected for this webinar, but sometimes we get excited with the whole content. We can expect for the next future that it will remain changing constantly because we are expecting to see better and better batteries, and some efforts are kind of pushing not just the heavy duty vehicles, also passenger vehicles to be able to charge at megawatt range. So that it's really exciting to see from a power electronics perspective. Different charging options will serve different sectors, so no method is superior than other one. Modular converters will remain to be the way, but probably we will have different class of modules because for powers beyond the megawatt, we might need to use a granularity a bit higher. Because of this tenfold increase in the output power, we could use more novelty. We could use more sophisticated front ends. We could see more and more solid state transformer based solutions or multi-level grid interfaces to guarantee that the power being provided into our batteries is actually done in a safer and a grid friendly way. And finally, the integration of all our heavy duty roads will highly challenge infrastructure. So from a regulation perspective and also from a power system perspective, there is a lot of challenges in the future, and hopefully we will solve them in the best possible way. So that's it. That's our presentation, and thank you very much for participating.